Hey guys, good morning and welcome to Balanced versus Unbalanced Forces. So, as you know that physics is a science of nature, so as for today we're going to explain many things that happen around us and we do not really know why are they happening that way. So, we're going to answer many questions about motion, okay? We're going to understand why are some objects remain stand still in their places, while if an object is moving, what could happen for this object to accelerate, to speed up, or what could happen to this moving object to slow down. So these are all also actions of forces, and we're going to compare the forces to know how they act together. All right, so here we go. We need to start with Newton's third law, which is the law of the reactions and reactions. So as for anything which is standing still, okay, this object is having a force, and you know this force which is its weight, right? And if this book is exerting a force downward with its weight, okay, and this book is placed originally on a desk, right? And actually this desk is also not moving and it's not cracking. Okay, it's not moving downwards and it's stable. So this means that the desk as well is making another opposite force. Okay, and we call this force the reaction force. So again, if an object is placed on a desk, for example, okay, and the desk can bear this weight, so this means that both the book and the desk are making forces, okay, but these forces are acting opposite to each other. And since the desk is not moving, so this means that the action force or the applied force that the book is doing on the desk is exactly equal to the force which is the desk is doing upward to or onto the book. Okay, so for every action, there is an equal and opposite reaction. This is what Newton's third law states. Okay, and because these forces are equal, so nothing is moving, neither the desk nor the book. Okay, so this is how we understand that an object remains stand still, right? Now let's elaborate more on the forces that act on a moving object. Okay, so let's take the example of the fish. Now, the fish has a weight, which is a force acting downwards, and the upthrust, which is the force acting upward in fluids. Okay, and this is water, so water particles are exerting an upward force on this fish, right? While the fish is moving forward, it needs a force, which is the thrust force, and the friction, which is the water resistance, actually resists the movement of the fish to backwards. Alright, now regarding another example, which is the boat. Also, the weight is acting downwards. Now the upthrust is making the boat actually floating, right? Also, the boat has an engine or something to give it its power to move forward, which is the thrust, right? And we have both air resistance and friction, which are the forces that oppose the movement of the thrust and they act opposite to the thrust direction, right? So balanced and unbalanced forces, we're going to speak first about the balanced forces, okay? And this is to mention that if you remember, let's recall what we have already mentioned in the example of the skydiving, right? And when you just drop yourself from the airplane, so the gravity was more than the air resistance, right? So this time you speed up. But now let's focus about the moment after some time when you stretch your body and you find that the air resistance becomes exactly equal to the gravity. At this time, you never stops, but you still go downwards with a constant speed, This means that your speed is not changing, right? So you are neither slowing down nor speeding up. So this means that the forces around you are balancing, which are the gravity and the air resistance are balancing. Balancing means that the forces are equal and opposite in their direction. equal in their size, or we can say magnitude, and they are opposite in their direction. The air resistance is acting downwards while the gravity is acting upwards. Alright, so at this time you have balanced forces around you, so you maintain your speed. Okay, let's speak of the unbalanced forces. Remember when you suddenly open the parachute in the skydiving example as well, right? Now, what happens is you increase the surface area, right? So when you increase the surface area, the air resistance is increasing as well, right? Okay, and now the resistance is bigger than the gravity. Okay, what happens at this specific moment? Because the forces are unbalanced, they are not equal, the air resistance is bigger than the gravity, so you slow down, right? This is what we have already mentioned and explained in the skydiving journey, right? So when there is an unbalanced forces around you, there's a change in motion that happens. And the change that happens to you in the skydiving once you open the parachute was that you slow down, right? So your speed is actually decreasing, okay, or going down. Another effect of the unbalanced forces is to change the direction. And I mentioned in the classroom that if you are driving safely, right, and a big lorry or another car which is very fast just came past by you, okay, so you suddenly feel that your car is not stable, right, for this specific moment. Does this mean that maybe the direction also can cause change? Sorry, maybe the unbalanced forces can cause change. Why did this happen? Actually, because when the car passed by you, some air particles are suddenly rushing into you, okay, and you're not used to this before the car passed by you, right? So this causes unbalancing in the forces for a moment, and this might cause you to feel that the car is changing its direction, right? And we have so many examples to elaborate for today, okay? Let's take the first example, and you're playing this game. This game is very familiar, okay? So the guy on the left-hand side is pulling your hands with a 6 newtons force, while the guy on the right-hand side, wearing the green shirt, is pulling in the opposite direction with 3 newtons. Okay, right? So who's going to win? Obviously, you know that the blue guy, or the guy who's wearing a blue shirt, is going to win. Why? Because actually he's exerting a bigger force, right? In this case, the forces are not equal because 6 newtons versus 3 newtons, right? So we have 3 newtons more in favor of the blue shirt guy, right? So he's going to win, and the force is going to act in his direction, right? And the difference between the force is 3 newtons, 6 minus 3, right? Let's go for another example, which is the tug of war, and we have already played this game in the playing ground, right? And the green team, or the team on the right hand side, is pulling with a force which is obviously bigger than the team on the left hand side, right? How did we know that they are pulling with a bigger force? That the arrow's lengths are different, right? The blue arrow is longer than the red arrow, which means that the team on the right hand side is pulling with a bigger force, right? So this means that the right hand side team is going to win because he's exerting more force, right? So there is a change in direction that happens, right? A change in direction which is towards the right hand side. Okay, why? Because there is a difference in forces. The team on the right hand side actually is pulling with 10 newtons, while the one on the left hand side is pulling with only 4, right? And the difference between them is actually 6 newtons. That's what we call the resultant force, or the net force, and this is very important term to remember. Okay, now more examples on the unbalanced forces. Now, the lady and the boy are pushing the ball. Okay, this time they are both pushing in the same direction. Okay, so we need to calculate the resultant, or the net force. In this case, we do not subtract the forces because actually the forces are acting in the same direction, right? So we're going to sum up or to add them up in order to imagine how much force is going to be used in order to push this ball, right? So let's agree that if the forces are acting in the opposite direction and we need to calculate the net force, we're going to subtract them, right? And if the forces are acting in the same direction, we're going to add or sum them up, okay? So the net force here is 15 newtons because we summed up or we added the forces of the lady together with the guy. Okay, now this girl is skating between two fans, and the fans, each one of them is making a force. An equal force is being experienced by the girl, so the girl actually is not moving. Now, if we use only one fan, now this is a case of unbalanced forces, right? Only one fan is exerting a force. That's why a change in direction happened and the girl moved to the left-hand side. Right. For this example, you just need to calculate the net force and to conclude at which direction will the ball move. So now you have two forces in opposite direction to each other. So you need to subtract them, right? 30 minus 10 is 20. And 20 in favor of which force? In favor of the forces acting downwards. So this means that the ball is going to act downward with a resultant force of 20 newtons. This case, the forces are balanced and equal, so no change in motion will happen and the ball will remain still. The third example, now you have two forces, but the bigger one is towards the upward, okay? And it exceeds the downward force by 15 newtons. How did I do that? I subtracted 30 from 45, right? So this ball is going to move upwards with a 15 newtons value force, right? Okay, the last example, this ball is going to move to the left-hand side, right? Why? Because the left-hand side force is actually bigger than the right-hand side force and they are acting in the opposite direction. Okay, I hope that is now really good. Let's check the other examples. Now the car is traveling already at a constant speed of 50 kilometers per hour. This is a moving object. And imagine that there are some forces acting on it. 15 newtons backwards and 500 newtons backwards, while 500 newtons forward. So now what do you imagine to happen in the car if it's already moving? Since the forces are balanced, so no change is going to happen. And the car is going to remain moving at the same speed. Right? Now, the same car having the same forces, but a wind, for example, or a crosswind comes from the sideways. Okay, so now this is a case of unbalanced forces because the upward force opposite to the crosswind is actually zero, right? So this car is going to experience a change in direction. Okay, it can move to the side to the side a little bit, right? Because there is a certain force which is acting on its side. Okay. Again, a lorry or a truck is moving at constant speed. Okay, it's already moving, and the forces are denoted as 500 newtons forward and 400 newtons backward. So now the forces are not balanced. Okay, so definitely there will be a change in the speed, okay, or even the direction, or both, okay. So the resultant force is going to be 100 newtons, and this car is going to move more towards the right hand side. So this means that this car is going to speed up. Okay. Or in other words, we can say accelerating. Accelerating means that the car is going to speed up. Alright, so this is the summary of today's lesson. Again, this lesson is very important. This is the core lesson of forces, and almost all of the questions on forces are using this point to question about. So if the forces are balanced, so no change in motion. If the object is stationary, it will remain stationary. If the object is moving at constant speed, it will remain moving at the same constant speed. While now, if the forces are unbalanced, okay, and the object already was stationary, and suddenly one thing or a wind or you pushed the object. So now when you push the object, the forces become unbalanced, and now there will be a change in either the direction or the speed of the object, okay, or both, okay. So this is the effect of the unbalanced forces together with the balanced forces. Now let's take more advanced examples. So what will be the resultant force on the satellites? Okay, you have 5 newtons and 5 newtons acting both upwards. So because they are both acting in the same direction, we're going to sum them up. So upward force is a total of 10, while the downward force is a total of 20. So because they are acting in opposite direction, we need to subtract them to get the resultant force or the net force, which is 10 newtons down. Right, now the satellite is going to accelerate downwards. Oh, this means that it's going to move downwards, okay, and will have a change in its speed, okay, or to speed up, right? For this example, now you have two horizontal forces equal to each other, so they merely cancel each other. So this bird will remain moving at the same constant speed. Now, speaking of the vertical forces, okay, you have 5 newtons downwards, right? And there is no force mentioned acting upwards, so you consider it 0. Right, now you have resultant force for the vertical forces is only 5 newtons, okay? So this bird is going to move slightly downwards, and there will be no change in its speed because the horizontal forces are equal in size, right? Okay, now for this yacht, you have 10 and 20 newtons thrust, so totally 30, and the opposite force is 13 newtons. So now for the horizontal forces that affect the speed of this boat, you're going to subtract 13 from 30, so you get 17, right? While the upward and down forces are exactly equal to each other, so there is no change in the height of this boat, so this boat will continue floating, okay. All right, so again, this boat is going to speed up because it has more force towards the right hand side, and the right hand side is already the forward force of the boat. All right, please don't forget to have fun with these animations on the forces. We have already made it in the classroom. You can try more and more examples in the same game. And thank you very much for being with me today. Please don't forget to study well, study from the notes, study from the workbook and the revision sheets that I'm going to provide you the next week. All right, and please sleep early and study written and not orally. All right, see you the next week. Bye bye.